In this video, we're going to talk about the function f of x equals sine of x. Now, take something to be true in real life. So, for example, a circle of radius 1. So from here to here, it has a radius of 1. And what I mean by true in real life, well, if you look at a triangle, say 2, 3, 3, 4, 5. This is a right angle triangle and it's true in real life. And from this triangle, from our section on trigonometry, we managed to deduce a lot of things just from taking something that's true in real life. So another one is when we had a regular triangle when it's 1, 1, 1. You see, this here is true in real life, and by extracting things that are true in real life, you can deduce a lot of other things from it. So, for example, you can split this down here, and then you can work out the area of this triangle, and you can do lots of other things. Take something that's true in real life. For example, a square of length 1, 1. Draw a straight line down here, and this angle here is 45. And then well, this here is true in real life. You can have a length of 1 or a length of 1, and this length here is root 2. And by doing this, by looking at something that happens to be true in real life, you can actually deduce that, let's say, let's say sine 45. By looking at this square here, you can deduce that sine 45 equals 1 divided by root 2, because sine is like this, isn't it? Sine. So by extracting things that are true in real life, you can deduce a lot of other things. So anyway, this here, this is true in real life. There exists a circle of radius 1 in real life. Okay, so let's just take a circle of radius 1. Now, and let's say we've got a point that is moving around this circle here. Okay, now let's say that this point here is, just for argument's sake, it's here. It could be up here, it could be over here. It's moving around the circumference of this circle, but let's just say it's here. Okay, so draw a straight line from our point to the origin here. So let's just call this angle here theta. Theta is the because we are moving around like this. Let's just say that this angle here is theta. And then draw a vertical line down here, and then you will have yourself a right angle triangle. So let me just enlarge it. So it's like this. Okay, the point is here, the origin is here. Okay, so you've got yourself a right angle triangle here. Theta is here. Now, it doesn't matter what theta is. Let's just call it theta for the time being. We are interested in the height. Let's say the height here is y. What is the height of this? When theta is theta, when the angle is theta. Okay, so the height here from our section on trigonometry, the c is here. If you don't understand this bit, then you've got to work. This is something that I made up. So if you don't understand it, watch the trigonometry section here. So we want to find out the height. So the sun is here, the sea is here, you're lying on the beach here. This here, you get a sun tan, and then this here, a sine to heaven. So this is sine here, and this here is cos. Okay. Now, if you want to know the height of this thing, you would use sine, because you've got the height here. Well, you want to know the height, and by the way, this length here is this length here, which is 1, because we've got a circle of radius 1. So as well, the radius is always 1, so the hypotenuse here is 1. Okay. If you want to know the height here, it would be, well, we've established that we want to know y, and we've been given the hypotenuse, so we have to use sine. So it's always sine the angle, sine theta equals, well, remember that we want to find out the height. So it would be y divided by the hypotenuse, which is 1. So y divided by 1 is 1. So you see the height of this of this triangle here is given by sine theta. Okay, so this height here is actually sine theta. Now let's just say that the dot is right here. Okay, so draw a line here, and then draw another one here. So this here is of the hypotenuse is 1. So let me just enlarge this triangle here. It's a lot steeper now. So this here is the origin. Okay, this is our point here. So this point here is here. Okay, right angle triangle here, theta is here. It's a lot steeper. Now we want to know why. Remember, the hypotenuse is still 1. It's still 1 because the radius of the circle is 1. And this angle here is theta. This theta here is just bigger than the previous theta. But let's just call it theta. Now the height here is, well, we're going to need sine again. So it's sine the angle, which is theta, and then that equals y divided by 1. Y divided by 1, which is just y. So again, the height of this circle is given by sine of theta. So when you, even though you're here, the height of this thing here is given by sine of theta. If the dot is here, it's still sine of theta. The height here is still sine of theta. Now if the dot is up here, again it's still if the dot is up here, it's still the height here. The height here is still sine theta. And here's a weird thing: even if you go beyond 90 degrees, let's say let's say it's here. So this angle here is 100. You see, when you do sine of 100 here, it's actually this height here. It gives you this height here. So as we move, as this circle moves around the circumference of this circle here, we can plot a table basically. Now you see what I'm trying to get at later on. So theta here, as you move around, so theta 0 is when the dot is here. The angle here is 0. So the height is 0. The height above the x-axis is 0. Now, hang on. Let's say it's at 30 degrees. I'm going to guess 30 degrees to be here. So this here is 30. When it's at 30, the height here, well, punch into your calculator, sine of 30. Make sure you're in degrees, okay? Sine of 30. Well, when the dot is at 30 degrees here, the height here is given by 0.5. Okay, the height here is given by 0.5. If let's say you're at 45 degrees, so this here is at 45 degrees. The height here is 0.7, and so on. So as you move along the circumference here, even if you're let's say 200, okay, from here to here is 90 degrees. Oh, when you are at 90 degrees here, the height is actually the radius, which is 1. Okay, when you are 110, which is around here somewhere, punch in this angle here, and it will still give you the height. This one here is 180 degrees. So when you punch in sine of 180 here, the height of this dot here will be 0. If you punch in 200 here, let's say, well, from here to here is 180. So 200, I'm going to guess to be around here. Okay, so 200 from here to here. Hang on. So 200, I'm going to guess, is around here. Oops, hang on. You see, from here to here is 200. When you punch in sine 200, it will give you this height here, which happens to be negative 0.34. So this height here is negative 0.34, and 270 is, well, 90 is from here, another 90 is 180, another 90, it will be 270. So 270 would be this angle here, and this would give us a height of negative 1. So you see, when an angle is of 270, it gives us a height of negative 1. And 360 will take you back to 0. That's why when you punch in sine 360, it will be 0. And if you draw a graph, if you try and plot a graph, you see when the angle is 0, the height is 0. When it's at, let's say, 90 degrees, then it's the height is 1. So when the angle is 90 degrees, the height is 1. When it is 180, the height is 0. So you see this point here translates to over here. Okay, and then here it translates to, well, don't forget this is like the height. You're plotting a graph of height versus the angle. So the angle is changing all the time. It's moving around here like this. Well, anyway, when it's 270, well, this is 270 here. It will be negative 1. So 270 negative 1 will be here. Okay, and when it's 360, it's back to 0. Basically, when it's here, as it turns out, it will be like this. It will be as this here is y equals sine of theta here. Okay. Now theta is just moving. Theta is just increasing all the time. It's just a number that increases all the time. So we could actually just use x instead of theta, because x just represents a number that changes. Here theta changes, so we can plot a graph of y against x, or we can use theta. Theta is just a number that increases, so x is just a number that increases, so we can change theta and x around. It doesn't matter. Yeah, so the graph will turn out to be like this. I will elaborate more on it on the next video, but let me just show you something here. Let's look at this bit here. Just ignore the top part here. You see, as you move around the circle here, you will, yeah, the height is given by this wave-like curve. That's why you've, yeah, that's why you've got this thing here. I will elaborate more on it next time around.